Interest problems. We are going to look at simple interest and compound interest. So simple interest has a formula. To calculate the simple interest, you take the capital or the principal, you multiply it by the interest rate, and then however many years it's going to increase. So for instance, if you borrow 100 and you have 5% interest rate, what is the interest per year going to be? If you borrow 100 and the interest is 5% per year,
It's going to be $5.
it's going to be $5. $5. If you borrow that for 5 years, what's the total interest? 25. This is simple interest. This is how simple interest is. It doesn't change. I've taught this for many years, and I've never understood why. Because you always get compound interest whenever I've dealt with a bank. However, when I bought a car last year here in the UAE, it's simple interest that they're using. Islamic banking, exactly. So it's simple interest. I'm like, right. So it is used, and this is how it's used. So the advantage on when you're working with this type of a situation, it's really important to pay it back quickly with simple interest. Otherwise, you're paying interest on money that you've already paid most of it back. So it's better to pay it back quickly with this. Let's have a go at some calculations.
Interest rate.
Make sure you're familiar with what the letters mean. C for your capital, R for your interest rate, N for the number of interest periods. I like that phrasing. And I for the total interest. So look at a wordy question. So an amount of 5,000 UK pounds is invested at a simple interest rate of 3% per annum for a period of 8 years. Per annum means for every year. Am I recording? Yes. Okay. Calculate the interest received after 8 years. So what was the formula?
It was C times R times N.
So the formula was I equals C
times R times
N. And what did the C stand for?
The capital or the principal?
So the principal, 5,000. And R?
Interest rate?
3%. And N?
Number of interest periods.
Number of interest periods. So if it's per annum and 8 years, that's 8 periods. If we type this into our calculators, what do we get?
1,200.
1,200. UK pounds. B. Find the total amount in the account after 8 years. So what would the formula be here?
Wouldn't we just add the original to
It would be the original plus the interest.
It's 6,200, is it?
It would be the original plus the interest. Sorry, let me just pause. What is that called? That would be the future value. So the capital might be referred to as the present value. I'm using these letters intentionally. Future value. Present value. So we calculate that as being present value plus interest, which gives us 5,000 plus 1,200 is equal to 6,200. if we look at how much in his bank account, how much is there at the beginning of the first year?
After 1 year. Beginning.
No, at the beginning of the first year.
Oh, 5,000.
5,000. How much is there at the end of the first year?
5,150.
How do you get the 150?
Because
3%.
3% of 5,000. What would be there the following year? What would be there at the end of the second year?
5,000.
So you're calculating the interest, which is 5. Let me clear my page.
So this is all just like one arithmetic sequence with extra steps. Is it not?
Okay, so this is the interest every year. It's simple interest, so it doesn't change every year. So we get, we start with this much the first year, and then we add the interest, and then we add the interest again, and then the interest again, and then the interest again. So this is what is in his bank account over the 5 years, these ones. Is this an arithmetic or geometric sequence?
Arithmetic.
This is an arithmetic sequence.
Oh, yeah, sorry.
This is the arithmetic sequence. So how much is, which term in the arithmetic sequence is how much is there at the beginning? U1. Which term in the arithmetic sequence is how much is in the bank at the end of the 5th year?
U5.
Oh, wait, no, U6, sorry.
Is it U6?
U6.
Yeah.
Why is it U6?
Because after 0 years, it's U1. So after 5 years, it's...
The initial principle is U1. So U1 is 0 years. U2 is 1 year. U6 is 5 years. So take care of just thinking it through a little bit like that when working with arithmetic sequences in this type of a problem. Okay. Ridhi! She's not here! The questions. Ridhi invests 5,000 in a bank account with simple interest rate of 7.3% per year.
4,000 in the bank.
4,000. Find the number of years it takes for Ridhi's money to double. Have a go at this for yourselves for a little while. Have a go at this for yourselves for a little while.
It's gonna come fast.
No, it's 0.0. Found it 27.4.
Yeah, I see it. Yeah. I saw it. Is it filming?
Which one?
Is it?
Let me see.
0.07. This one.
Do you get like small? Are you the people? It's okay.
How did you even do this question?
Wait, here, what do you got?
27.4.
Let's have a look at the equation.
Yeah.
Let's have a look at the equation. So we want double the amount. So we start with this in the bank, and then we add this much interest. For this many years.
Yeah.
This is our equation. Notice the 4,000 in every term.
You can simplify.
Put that into our end solve.
27.4.
End solve it.
27.4. But that's not that's.
N equals 27.4.
So the answer would actually be 28 then.
Let's read the question.
No, but you can have 27.4 years.
Find the number of years it takes for Rudy's money to double. Now,
It's 27 years and 3 more.
we have to think this through. So during the first year, in May of the first year, how much is in the bank account?
4,000.
The thing is,
In November of the first year, how much is in the bank account?
still 4,000 it says yearly, not annually, not monthly.
yeah, no, you're right.
How often is the interest given?
Once per
year.
Once per year. So for the whole first year, it's 4,000. So if we need it to double, in the 27th year, at no point has it doubled.
So 27.4 doesn't mean anything.
24.
It can do if it's continuous growth.
Like
Let's
if every
say-
second
No, banks have interesting periods usually, and they calculate interest every so often. It gets a bit complicated, but for instance, if you were talking about some kind of a growth that was like bacterial growth, that would be a continuous.
Always, every
Yeah, that's a continuous growth. Whereas these type of models, they're not continuous growth; they are compounded. Compound growth is different to continuous exponential growth. They look similar-ish, not quite. So we go 28 years. All right, compound interest. In general, if you invest in a present value of PV, the rate of interest R compounded annually, the number of years is N, then the future value is found using this model. So this model. This is where R is a percent. If you convert it to a decimal, you don't need to do the divide by 100. I'll show you. So that divide by 100, that's a horrible thing. Peter invests 2,000 Australian dollars in a bank that offers simple interest at a rate of 3% per annum. Paul invests 2,000 in another bank that offers 2.9% interest compounded annually. Calculate how much money they each have in the bank after 10 years. So we need Peter. So we need Peter. After 10 years, it is going to be 2,000 plus 2,000 times, what's the interest rate? 3% for him.
2,600.
Times how many years? Okay. Put this into our calculator, what do we get?
2,600.
2,300, is it?
600. Wait, 2,000, yeah, 2,600.
Can we put it into the calculator, please, everybody?
Sir, question. It says after 10 years, so would that be 11
That would be 10.
But even if it says after.
1 second after 10 years.
26.
Just how they word it.
2,600.
Oh, that's 2,000. That's the extra 2. So this gives us 2,600. Make sure to mention that these are Australian dollars. Paul. So what's the formula?
The formula would be, the farm would be 2,000. 2,000.
Sorry, let me do this general. So let's write the formula up. The future value equals the present value, 1 plus R% divided by 100% to the n. This is on the formula sheet. But I will enter it like this for Paul. The present value is 2,000. This is 1.029 to the 10. Is it a good song? Is it, what's her name? Taylor Swift.
What?
I have no idea who's playing it,
off?
but because you liked it, I'm guessing it's Taylor Swift. Because you
Oh.
The answer would be 2,000.
Type it into your calculators now, everybody. Type it into your calculators now, everybody.
Yeah.
While you're on the untested.
So you already know. Oh, that's
If I leave, or if I actually go to outside, everyone. It's literally the day after.
It is.
Have you seen those TikTok videos of the South African guy?
Yeah.
So he's carrying this Christmas tree. Sorry, the wind snake down the tree. I walk home with it for 5 months. Then I call my son and point him up. Have you seen that video?
I think I saw a different person. My friends always send me this one clip of this African dude with dancing.
Oh, right. It's got
You want to do something?
You left the cable in me.
Are you going here or are you staying?
No, I love staying.
So you're staying.
I love saying it.
I did love staying here, but that's only because I didn't have any friends.
What do we like?
So you still don't like staying?
Sorry. What do we get here, guys? What do we get?
2,661.85.
2,661 point.
2,661.85.
Really? That's the thing.
Yeah, because if it's a currency, then it has to be two decimal places.
Currency 2 decimal places. Currency 2 decimal places, unless it ends in a 0 like that previous one. Then what's the point? What do we notice here? The interest is worse for Paul. He doesn't have as good an interest rate, but he's got more money.
Because that one is linear, this one's exponential.
Yeah, compound interest grows much faster. So if you get a lower rate of compound interest, you can still end up with more of a longer period. If you're borrowing at a rate, if you have a higher rate of interest, you pay it back quickly, it goes down quicker as well. So over long periods, compound interest grows really quickly, but also over long periods, if you're paying it back regularly, it goes down quickly too. Determine after how many years they will have the same, at least 5,000 in their
Very happy
account.
to bother with Paul actually, because we know that by the time Peter has $5,000, Paul will 100% have that much money.
Don't you just graph it and set the intersection?
But I think we have to do it individually for each, right?
No, we don't.
You don't, you want the smallest of the two. Oh, sorry, you want how many years they will each have at least.
Oh.
So then you really only need to do it for Peter.
Yeah.
Oh, okay. Oh, I just did it for Paul.
You only need to do it for Peter. But I think the best approach is the safe approach. And like Sophie says, graph it.
Oh yeah.
Because then you see it visually. So let's make sure we can graph these. So what is the formula for Peter? It is Can I simplify this one? Can I put Peters in like that? I believe I can.
Yes. Inshallah.
And then what about the other chap? What's he called? 4. He is 2,000 times 1.029.
Sir, do you think you could get the test results back by next class?
Can we finish this question and focus on what we're learning?
Yeah.
So, what's the first value in the bank account at the beginning year? So this 6 isn't really going to be much helpful here. So click here in your axes twice and change it to 4,000, shall we? We can see them going up. We want it to have at least doubled, don't we?
Yeah.
So we see we need to extend this axis a little bit more. So click on this twice. It's not even close to doubling, so we need to maybe put it up to about 50 for that one. There we go. So we wanted to find out when it's going to have 4,000. So 4,000 is a bit small. Let's make this one 4,200. And then we can add in the graph y equals 4,000.
At least 5,000.
This is the threshold we want it to pass.
Oh yeah, it's not.
This is the threshold we want it to pass.
It's not doubled. It's asking for at least 5,000.
Yeah.
Oh, at least 5,000, right? So
5,200 and then
let's change this one to 5,000,
yeah,
and then change the y-axis up a little bit higher to 5,500.
There is. Do you want a smaller one?
No, because they both have to have doubled. So at
yeah.
this point, the blue one hasn't gone to 5,000 yet. So let's make that go a little bit further here, like that. There we go. So here at this point, the blue one hasn't got to 5,000. So we want to find the intersection of this graph and this graph. What happens there? Ooh. No. Undo. There's an undo button
When
somewhere.
you do Control Z, try doing Control Z.
I don't know. It just grabbed it for some reason. Intersection. We want this graph and this graph,
That would be 50 years.
and it happens about there.
Exactly.
It happens at 50 years.
Oh, I just realized we could have like mentally calculated that.
I think it's nice to see.
I like the graph.
It's nice to see the graph in this case. And so you visually help stop making the mistakes. So we get after 50 years. Okay, have a go at these questions for homework. Faster? Yep, let me just pause our video for our online